Okay, welcome back. I actually accidentally stopped the previous video, and I'm going to pick it up now at number 4, which asks us to determine if a student who announced that the measure of the angle which subtends this arc length of 1.2 inches in a circle of 1.5 inch radius. A student makes the statement that the measure of this angle is 1.2 inches. Is this an appropriate measure? Why or why not? So hopefully you all see, and this is just again something we've seen already and something we're trying to drive the point home about, is that we can't simply use a linear measure to determine the amount of openness which subtends a given arc length. Now, 1.2 inches and 1.5 inches are part of the bigger picture, in that the 1.5 inch radius dictates the size of the circumference, and ultimately this arc of 1.2 inches is going to represent a fraction of that circumference. But to say that this linear measure of this arc is 1.2 inches is subtended by an angle of 1.2 inches is obviously not correct. A better way to think about this is knowing that our radius length is 1.5 inches, and correspondingly an angle measure of 1 radian will subtend an arc of 1.5 inches, is we can ask what percent 1.2 is of a radian, and 1.2 divided by, right? And this is going to give us 0.8, and this is in fact 0.8, our degree measure in radians. And again, we go back to the previous video. Recall that we said theta in radians will be equivalent to the arc it subtends divided by the radius of a given circle. All right, so the final exercise we want to look at in investigation 2 is this bug on the tip of a fan blade context, which we'll be using quite a bit going forward to help establish an understanding of the sine and cosine functions. Here we just want to get your feet wet with it, and we have a bug that is 2.6 feet from the center of this fan blade, and they're saying he starts at the 3 o'clock position. I should say he or she, we don't know its gender. And it rotates in this direction, they say in part A, 5.2 feet. So it's going to travel 5.2 feet. Let's see, it's about, I don't know, I'm guesstimating, about there. Hopefully you all see that 5.2 is twice the length of the radius, and so the degree measure, the corresponding degree measure, theta, is what? Well, if the radius is 2.6 and we've traveled 2 radii in length along this arc, well then we would expect theta to be 2 radians. Or we could use the fact that theta in radians, just like we saw in the previous example, is going to be given by how many times as large is a given arc for a circle, how many times larger is the arc subtended by that angle than the length of the radius, 2.6. And we would get, of course, 2 radians. The mouse is just not working for me here. 2 radians. All right, so for A we got 2 radians. Again, that's just using the fact that theta in radians will be given by the arc divided by the radius, or the length of 1 radian. And now, similar question in B, we could maybe intuit the result. So 5.2 is 2 radians, and 10.4 would be 4 radians. We've gone more than halfway around the circle in that case. And then about 1.3 more feet. I don't know, let's figure this out. So again, that's going to be theta will equal 11.7 over the length of 1 radian, and that gives us 4.5 radians. 4.5 radians. In C, we're attempting to, I suppose, restate what we've already established. So they want us to express theta in terms of the arc length it subtends and the radius, and we know that theta will be given by an arc length, with the corresponding arc length it subtends divided by the length of the radius, or the length of 1 radian. Okay, so if we take this relationship, theta in radians will be equivalent to the arc it subtends divided by the length of the radius, or the length of 1 radian. And they're asking us, if the radius of the fan, if this doubles, how will the arc length S change? Well, since we're dealing with theta, since theta is in radians, and this only applies for theta in radians, hope you all see that, if the radius doubles, well, then the arc length is going to have to double. And I guess the easiest way to see this is to say, okay, well, if 1 theta is equal to S over R, well then, in order to maintain truth here, truth in this equality, if I'm doubling the radius, well, and I do nothing else, I am multiplying the right side of the equation by 1/2 and not applying the same thing to the left side of the equation. So to maintain truth here, I need to, I can only multiply this expression S over R by 1. And I hope this makes it clear that we maintain the fact here, because 2 over 2 is 1, that theta is going to will still equal S over R. Okay, so when we come back in the next video, we will pick it up in investigation 3 with this same context, dealing with this bug on the tip of the fan blade being swept out from the 3 o'clock position, and we will introduce the notion of a trigonometric function. I recommend to all of you, before you come back from break, that you've gone through investigations 1 and 2, at least gone through these videos, and 3, if you could find the time, and have a nice break.